Okay, so let's see, we're on page 210 and 211. We were looking at the relative risk reduction calculation and the absolute risk reduction calculation. So let's just go back and review the calculations. So for relative risk reduction, the calculation will determine whether there is less risk or more risk. The relative risk reduction, RRR, is calculated after the risk reduction and indicates how much the risk is reduced in the treatment group compared to the control group. So let's see here. We had our previous data where we have our percent risk in control group, our percent risk in treatment group, and so we do percent risk in control group minus percent risk in treatment group, and then we divide that by the percent risk in the control group. And so using some previous data from our scenario with metoprolol versus placebo, we had a 28% minus 16% divided by 28% equaled 0.43. So the relative risk reduction interpretation is that the relative risk reduction is 43%. Metoprolol treated patients were 43% less likely to have heart failure progression than the placebo treated patients. And then the absolute risk reduction, the clinician is listening to a presentation on a drug, and the drug manufacturer representative reports that the drug causes 48% less nausea than the standard treatment. So the result sounds great. The clinician asks the representative, what is the absolute risk reduction, or the ARR? So to remind us, the relative risk and the relative risk reduction provide relative proportional differences in risk between the treatment group and the control group. They have no meaning in terms of absolute risk. The absolute risk reduction is more useful because it includes the reduction in risk and the incidence rate of the outcome. If the risk of nausea is reduced but the risk was small to begin with, perhaps the drug caused very little nausea, the large risk reduction has little practical benefit. It is best if a study reports the absolute risk reduction and the relative risk reduction, and for clinicians to understand how to interpret the risk for their patients. So if the absolute risk reduction is not reported, it is possible that the risk reduction in terms of a decrease in absolute risk is likely to be minimal. So this formula is going to be percent risk in control group minus percent risk in treatment group. And so the percent risk in the control group turned out to be 0.28, and the percent risk in the treatment group came out to be 0.16. And so we can look at our formulas on the top of page 211. So what that means is the absolute risk reduction is 0.28 minus 0.16, which is 0.12. You multiply that by 100, which is 12%. So the absolute risk reduction interpretation means that it's 12%, or 12 out of every 100 patients will benefit from this treatment. So said another way, for every 100 patients treated with metoprolol, in our scenario, 12 fewer patients will have heart failure progression. An additional benefit of calculating the absolute risk reduction is to be able to use the inverse of the ARR to determine the number needed to treat and the number needed to harm, NNT and NNH. So continuing on page 211 with number needed to treat or harm, this helps clinicians answer the question, how many patients need to receive the drug for one patient to get a benefit? This information taken into consideration with the patient's individual risk helps us guide our clinical decisions. So with the NNT, number needed to treat, this is the number of patients who need to be treated for a certain period of time, for example, 1 year, in order for one patient to benefit. For example, for the one patient to avoid a heart failure progression. So we can see the math here. There's some formulas bottom of page 211. So the NNT formula equals 1 over risk in control minus risk in treatment groups, which is 1 over ARR is your number needed to treat. So for us, we had 1 over 0.12, and that equals 8.3, which is rounded up to 9, because we can't treat parts of patients, we have to treat the whole patient. So the interpretation for number needed to treat is for every 9 patients who receive metoprolol for 1 year, heart failure progression is prevented in 1 patient. On page 212, we have number needed to harm. So that NNH is the number of patients who need to be treated for a certain period of time in order for one patient to experience harm. So these are calculated with the same formula, and there are 2 differences. So the NNT will be rounded up and the NNH is rounded down. The absolute value of the ARR is used with NNH, and it's shown in our example. So let's do the NNH calculation. A study evaluated the efficacy of clopidogrel versus placebo. Both were given in addition to aspirin in reducing the risk of cardiovascular death, MI, and stroke. The study reported a 3.9% risk of major bleeding in the treatment group and a 2.8% risk of major bleeding in the control group. So the ARR is 2.8 minus 3.9, which is negative 1.1%. The absolute value is the difference between the 2 groups. So there is a 1.1% higher risk of major bleeding in the treatment group. So the number needed to harm is 1 over the absolute risk reduction, which is 0.011. So that is 90.9, or rounded to 90. So the interpretation for number needed to harm is 1 additional case of major bleeding is expected to occur for every 90 patients taking clopidogrel instead of just the placebo. And let's take a look here. We have some concepts that we're going to review of odds ratio and hazard ratio next.